Do you actually want to learn how to use Metasploit today without years of guesswork? In the next 15 minutes I'll walk you through what Metasploit is, why it's organized the way it is, how to set up a safe lab on Windows, and 2 clear beginner-only demos that teach the exact pattern you'll reuse over and over. Pick a module, configure the options, pick a payload, and start the listener, all inside an isolated environment you control. If you want bite-sized practical skill, hit like and subscribe now, and I'll make more lab packs and command sheets you can download. Everything I show is only for your own devices and virtual machines. Don't test against any network or system you don't own or have explicit permission to test. Practice on snapshots so you can revert, and always keep your lab offline or on a separate host-only network. Okay, now let's make this practical. First, what is Metasploit? In plain English. Imagine you have a Swift Army knife for security testing. Metasploit is that toolbox plus an instruction manual and a workshop. Inside the toolbox are modules, small pieces of code that each do one job. Small modules scan targets, some try exploits, and others deliver payloads. You can think of an exploit as the method you use to open the door, the trick that takes advantage of a specific vulnerability, and the payload as what you send through that door. For example, a remote shell or a Metasploit session which gives you an interactive connection back to your machine. The framework ties those pieces together so you don't have to wire everything manually. Here are the important terms explained right away so we're not confused later. rhost means remote host, the IP address of the target computer inside your lab. lhost means local host, the IP address of the machine running Metasploit that will receive callbacks from the payload. Port is simply the TCP or UDP port used by service or by listener. A listener or handler is the part of Metasploit that waits for a payload to call home, like you opening a phone and waiting for a callback. Auxiliary modules are non-exploit tools for reconnaissance or scanning. Post-exploitation tools are what you run after you have a session to explore or maintain persistence inside your lab environment. Quick analogy to make it stick. If an exploit is a key that opens a lock, then the payload is the person who walks through the door after it's opened, and the handler is the phone you leave on the table waiting for that person to call you back. If you mix the wrong key with the wrong lock, nothing happens, and if the phone number is wrong, the person can't call you. Now a note for Windows users. You don't need Linux to learn Metasploit or hacking. There are Windows installers and you can run Metasploit on Windows either natively or inside a small Linux VM while still using your Windows host. The important part is networking. Your lhost must be reachable from the target VM. If you use network address translation or NAT networking in VirtualBox or VMware, your target might not reach your host unless you bridge or use host-only mode and configure correctly. If you're unsure, use bridge networking to give both machines an IP on the same network segment. That's the simplest for beginners. If you prefer extra safety, use host-only network and only connect the attacker and target VMs to that private network. Alright, here's the roadmap for this video. First I'll show the basic pattern you'll repeat forever. Choose module, set rhost, lhost, and port, then choose payload, start handler, and run the exploit. Then we'll do 2 lab demos, one focused on an Android Metasploit payload running on an emulator or spare phone, and the second using a classic vulnerable FTP service on a Metasploitable style VM so you can see the exploit selection and module options. I'll explain every option you need to change and common mistakes so you don't get stuck. Demo number 1. The Android Metasploit flow. In this lab, you will build a payload that, when installed on an emulator or a disposable Android device you control, connects back to your Metasploit listener. Conceptually, the steps are picking a mobile-capable payload, setting lhost and lport to values your listener can use, packing the payload into an Android package file, installing it on the device, and running the handler. When the app runs on the device, the payload calls your lhost and lport, and you get an interactive session called Metasploit. Now you might ask, why each setting matters? Well, lhost tells the payload where to call back. If lhost is wrong or unreachable, the payload never connects. L port is the port on which your listener waits. If the payload tries a different port, there is no connection. Also note payload compatibility. Mobile payloads only run on Android, Windows payloads only run on Windows, and so on. If you try to deliver a Windows payload to Android, nothing will happen. This is a common beginner mistake. For demos, we package the payload into an Android package file and install it on a disposable phone. If nothing connects, check firewalls on your attacker machine first. Windows Defender can block incoming connections by default. The point of this demonstration is not to teach you social engineering or distribution. It's to teach the callback pattern, payload, callback to handler, and interactive session. Once you understand that pattern, you can move to other payloads in a lab safely. If you're following along, pause and confirm you have an Android emulator or a spare device, and that your Metasploit can listen on a reachable IP. If you just want to learn the pattern, keep watching, you'll still get the concept. Demo number 2. Exploiting a vulnerable FTP service like a VS-FTPD backdoor on a purposely vulnerable VM. The reason we do this is to show how to choose an exploit module based on reconnaissance and how to set module-specific options. The flow is: scan the target to identify services and versions, search Metasploit for matching exploit modules, read the module info to find required options, set rhost and rport, choose a compatible payload, and run the exploit. If the target is vulnerable in your lab, you'll see a success message and possibly a session will spawn. Before you exploit, you often use auxiliary scanner modules to confirm services and versions. This is like checking the model of a car before trying a key. If the scanner reports FTP and a version with a known vulnerable build, Metasploit likely has an exploit module you can test in your lab. Module info in MSF console lists required and optional options. The required ones are the ones you must set. Always read that info. Beginners often run modules without setting rhosts or forgetting to set the payload, which causes failure. Common troubleshooting checks. If an exploit fails, verify your rhosts correctly. Sometimes people swap rhost and lhost. Ping the target to ensure reachability, or check that the port is open with a simple port scan. Make sure firewalls are off inside the lab VM or configured to allow your test traffic. Use snapshots so you can reset it to a clean state if the experiment destabilizes the VM. Now, more about the handler and sessions. When you start a handler, Metasploit is waiting for a callback. When you run an exploit with an inline handler option, MSF console may automatically start the listener for you. When a session opens, Meterpreter or a shell gives you commands to interact with the target. In a lab, try harmless commands like listing files, checking system info, and taking a screenshot. Always revert the VM snapshot afterwards. One more practical comparison. Think of the exploit as a courier and the payload as a package. The courier needs to know where to deliver the package, and the package must be compatible with the destination. If the address is wrong, the courier returns to sender, and if the package does not match the door type, it won't fit. In Metasploit terms, the courier is the exploit module, the address is rhost, the package is the payload, and the handler is the mailbox that receives the call. Let's talk about common beginner mistakes and how to avoid them. Number 1. Networking misconfiguration. If the lhost is not reachable from rhost, you can test connectivity. Number 2. Firewall blocking callbacks. You can temporarily disable firewall in the lab or create rules for your listener port. Number 3. Wrong payload or platform combination. Always match payload to target OS. Number 4. Not reading module info. Modules clearly show required options and target compatibility. Number 5. Forgetting to snapshot before testing. Always take a VM snapshot so you can roll back if needed. By now, you should be seeing the repeated pattern. Pick module, configure options, choose payload, start handler or run exploit. Confirm session, and then post exploit safely in the lab. If you get comfortable with this flow, everything else is variations and edged cases. Here are the final practical tips for Windows users. Run Metasploit via the official installer or inside a small Linux VM. Configure your VM networking as bridged for easiest reachability. Add firewall rules that allow your chosen L port, and always run your attacking VM on a segmented network. If you're using a physical Android device, enable USB debugging only when needed and use a disposable test device to avoid personal data exposure. Here is a recap. Metasploit organizes functionality into modules. Exploits are methods, payloads are what you deliver, handler is the listener, and rhost, lhost, and port are the addressing system. Demonstration number 1 taught the payload callback pattern with Android Meterpreter. Demo number 2 taught exploit selection and module options using a vulnerable FTP service in a VM. Both demos are about learning patterns and safe lab practices and not attacking real targets. Before I close, here is the one last call to action. If you want the lab checklist, exact VM names, and a non-public command sheet I use when recording, hit me up on Instagram. Also, tell me which direction you want next. Deep dive into Meterpreter commands, pivoting inside a lab, or defensive detection. I'll make the follow-up based on votes. Thanks for watching. If this helped you level up, hit like, subscribe, and share it with one friend who is into cybersecurity. Keep practicing only on your equipment and VMs, snapshot everything, and be the kind of hacker who protects systems and not breaks them. I'll see you in the next lab. Peace.